Girl, if you were an isosurface, I'd extract you on a uniform grid to not lose any details. Hi everyone, welcome back to Pushing Voxels Forward. This is episode 5. Check this out. Boom, look at that. We have a torus, we have SnapMC working properly. Let me switch it to regular marching cubes real quick just so you can see what it looked like before. As you can see, we have a lot of thin triangles, especially right around here. Unfortunately, I can't change it between regular marching cubes and SnapMC on the fly. I have to restart it every time. Not that big of a deal, but such a big difference. We have 6,700 primitives versus 11,800. That is just an insane reduction. Check out how nice this looks. It's almost like not a single triangle has a minimal angle of anything less than, say, 30 degrees, 35 degrees. It's working significantly well. Admittedly though, some of the quality is a little rough on some patches. Like I'm pretty sure here we had some information lost, but we are snapping with a pretty high parameter. Let me go ahead and switch over to a screenshot I have here. So on the left is regular marching cubes, and on the right is SnapMC with the same parameters that we have set. So massive differences here. Just a side-by-side comparison. If you follow me on Twitter, you would have noticed that I posted this screenshot before. So there is a benefit to following me there in case you want to get a sneak preview of what's in the coming episodes so you don't have to wait as long. Alright, let's take a moment to talk about the performance real quick. So if you remember in the last episode, it took about 18 to 20 milliseconds, give or take, to extract a 63 cube torus. With SnapMC, it takes about 36 milliseconds, so it's about twice as slow on average to extract the surfaces. And that actually brings us to what we're going to be doing this episode, which is looking at how we can optimize it. So the first thing that you should always do when trying to improve the performance of your application is to benchmark it, or to run a profiler, and what that will do is show you basically what's taking the longest in your code so you know what you have to focus on. And you can if you're not familiar, in Visual Studio 2017 anyway, you can come up to here under the Analyze menu, go to Performance Profiler, it's the first option. Just click on Start, and then all you gotta do is click on Finish, and what it's gonna do is it's gonna run your program, and then it's gonna collect data for the usage of it. All you gotta do is just run it real quick, profile, or at least run it for what you want to test, close the application, and then you get something like this. And I won't really go into detail about how this all works, but here's a graph. I don't really ever pay attention to it, but down here you have the main functions that are taking the most time. So in the core run is where we actually have the SnapMC algorithm running. And if you were following along, what I was doing was you click here and then go to whichever function that you know you want to focus on. Obviously render is not what we're going to look at. Unfortunately, I ran the application a little bit too long, but if you click on these functions, it's going to take you closer and closer to where the most expensive line is. So just by looking here, we can see that the label edges is the most expensive part, and then it kind of breaks it down, and then we also have snap vertices, and then a big chunk of the performance is getting the gradient. So it really helps to narrow down where the performance is struggling. Now admittedly, I've already done a little bit of optimizing. I did run the profiler before recording and then worked at it a little bit, and I have a picture here of something that I took, or the first benchmark that I took, and I just found it really funny because you see this function, the important part of the code is here, and with everything that I talked about in the last episode, you think that cache performance would be the most important, but looking at it here, 25% of the total runtime was taken up by multiplying an integer by 3, according to this. Now, that's not right. you have to know that sometimes the sampler isn't the most accurate. The way that it works is it basically doesn't really freeze the application, but every so often it looks at the application and sees what line it's executing, and then just transfers all those samples into a report at the end. And for some reason it thought that most of the samples were coming from multiplier times equals 3, when really it was this function. Switching back to Visual Studio, I have it reprofiled with some improvements. First thing that I did was just I wanted to eliminate that was what was actually happening and just have a constant lookup table with the powers of 3. And as soon as I did that, this line here immediately became the most it actually, the percentage just shifted upwards, so it was like 26%. And then I just saw a small optimization where we only need to assign a corner vertex based on the mask or the grid sign. So that's how we were able to get that a little bit faster as well. Some profiling tips as well. Whenever you're, especially with voxels, whenever you're trying to sample a specific thing, you usually want to avoid any sort of expensive noise calculations or terrain generation, unless that's what you're trying to focus on. So I almost always will test with something like a torus or a sphere, because it's just a really simple equation. It doesn't involve heavy mathematics or noise calculations. Alright, so I'm sure that you guys know by now, but SnapMC is for the most part the same as the index marching cubes, but there is an additional pipeline stage in which after you generate all the edge crossings, you actually have to go back and then snap the grid vertices to the nearest iso vertex, which is what's basically described here. I did end up figuring it out. It's really not that complicated. I just didn't expect to have to insert an entire other pipeline stage. That's what let me see if I can find it real quick. That's what the snap vertices function is. And I'll just go through that real quick. After it calculates the edge crossings, as you can expect, it just cycles through, for each grid point, all the iso vertices on the edge that it's a part of, and then if any of them are shorter than a certain threshold, it just takes the shortest one of those, and then sets the grid sign to what is essentially 1 in this function. 1 means that it's on the it's on the surface, and then creates a new vertex. Another thing that I had to change from the last episode is grid signs no longer uses just an 8-bit integer array, it uses a 16-bit integer array, and for some reason I had forgotten, I guess, that signs require 2 bits, and for some reason I was only calculating it as if it had 8. So if we look at all the stuff here, it's a little bit more complicated. We have to AND it by 3 instead, and then the lookups are just a little bit, you just multiply the left shift mask by 2. Switching back to a mesh that we have, looking at the client bottle that I demonstrated in the last episode, again the mesh looks fantastic. I actually really want to experiment with the location smoothing. I'm just curious about how good the results are going to look. I can only imagine that most of the triangles will be nearly equilateral. But anyway, one of the downsides with SnapMC is that you end up with non-manifold vertices. If you can slightly tell here, that's a single vertex, and it is not, I forget what the analogy is, I guess like a 2-ring is what it's called. I'm not entirely sure about the topology terms, unfortunately. That's one of my downfalls, but it does not produce manifold mesh. I think this is a non-manifold edge as well here. But if you're not worried about UV coordinate generation with your textures or numerical simulations, you really don't have to worry about that. Well everyone, I'm afraid that that's going to have to do it for this episode. Apologies that I didn't really go into a whole lot, but I hope you enjoyed seeing SnapMC, the basics of optimizing. In the next episode, I'll try to actually go through all the optimizing that I do, so you can hopefully learn something along the way. I just would rather split that into another episode than kind of summarize everything and then also go into that. So, as always, be sure to check out voxelspace.net if you haven't already. Thank you all for watching, and I'll see you next time.